Imagine walking onto a factory floor, the familiar hum of machinery filling the air. But then you see a figure working alongside the human crew, moving with a fluidity and purpose that makes you do a double take. Is that a person? No. It's Figure 02, a humanoid robot, and the line between science fiction and factory reality just got irrevocably blurred. Could your job be next? Stay with us as we dissect the video that's sending shockwaves through the tech world and beyond. For months, maybe even years, Figure AI has been the quiet giant in the humanoid robotics arena. While some competitors were busy choreographing dance routines for their robots or programming backflips designed to go viral, admittedly cool, but perhaps not immediately practical, Figure AI adopted a different philosophy. Think of them as the engineers locked away in the workshop, covered in metaphorical grease, while others were out posing for the cameras. Their mission wasn't about generating fleeting internet fame. It was about tackling the stubborn, complex, real-world problems that have kept humanoid robots confined to labs and carefully controlled demonstrations. They weren't interested in gimmicks or empty hype. Their focus was singular, relentless, iterative engineering aimed at creating machines capable of performing actual, valuable work in the messy, unpredictable environments where humans operate every single day. And the results? Frankly, they're staggering. Consider this trajectory. In less than a year, 12 short months, Figure has propelled its creation from the relative safety of laboratory prototypes, performing simplified tasks under ideal conditions, to actual deployment within the demanding ecosystem of a BMW manufacturing facility. We're talking about one of the most technologically advanced, precision-focused automotive production lines on the planet. This isn't a test run in a cordoned-off area. This is integration. But the truly jaw-dropping aspect isn't just that they achieved this milestone. It's the way they achieved it and the sheer level of capability demonstrated. Let me walk you through what we're seeing, because words almost don't do it justice. What you're witnessing in that footage, that's not a carefully choreographed sequence run 100 times until perfect. That isn't some technician behind a curtain with a sophisticated remote control puppeteering the movements. No, that was Figure 02 operating fully autonomously. Think about that. A humanoid robot, untethered, navigating the inherent chaos of a live factory floor, a place with moving carts, unexpected obstacles, variable lighting, and human colleagues working nearby. It's making decisions in real time, adapting to minor variations, and performing tasks requiring delicate manipulation with a dexterity that, until now, felt exclusively human. This isn't just an improvement. It represents a fundamental leap, a paradigm shift in robotics. This is precisely what sets Figure AI apart from so much of the field. While numerous promising robotics projects are still deep in the research and development phase, perhaps demonstrating impressive individual skills in isolation, Figure AI leapfrogged that stage. They forged a strategic partnership with a global industrial powerhouse, BMW, and put their robot directly into the crucible. Instead of endless testing in sterile, predictable lab environments where every variable can be controlled, Figure 02 is facing the ultimate trial by fire. It's learning and proving itself where it truly counts, inside a dynamic, real-world factory, performing tasks that contribute to the actual production of vehicles. This move transforms the conversation. Humanoid robots are no longer just an exciting theoretical concept. Figure and BMW are demonstrating they are a practical, potentially necessary, evolution in automation, ready to be tested and refined in the demanding reality of modern manufacturing. First, consider its vision system. Watch closely how Figure 02 scans its surroundings. It's not merely detecting blobs or shapes. It's constructing a rich, three-dimensional understanding of its environment, processing visual data in a way remarkably similar to how you or I would size up a workspace. Observe how it precisely identifies the specific part it needs from a bin of similar items, positions its body and manipulators perfectly relative to the workstation, and subtly adjusts its approach based on the real-time visual feedback it receives. This isn't just object recognition. It's demonstrating sophisticated spatial reasoning and environmental awareness, capabilities that, just a handful of years ago, were firmly in the realm of science fiction speculation. Imagine trying to reach for a specific screw in a cluttered toolbox without looking directly at it. That's the level of spatial understanding we're starting to see. Then there's the manipulation. Pay attention to how it handles tools like that screwdriver. Notice the minute adjustments in its grip pressure, applying enough force to be effective, but not so much as to damage the tool or the workpiece. See how it compensates almost imperceptibly when a movement doesn't go exactly as planned, perhaps due to a slight variance in the part's position. Crucially, these are not rigid, pre-programmed sequences playing out like an old animatronic display. The robot is making constant microcorrections based on real-time tactile feedback streaming from sensors embedded in its hands. These sensors are approaching a level of sensitivity that allows the robot to feel its interaction with the world in a way analogous to our own sense of touch. Achieving this degree of fine motor control, this adaptive dexterity, in an untethered, fully autonomous system operating in a complex environment, it's genuinely unprecedented. Think about threading a needle. It requires sight, touch, and incredibly fine motor adjustments. That's the ballpark of complexity we're entering. But perhaps the most critical element, the real game changer, is the autonomy, particularly its ability to handle unexpected events. In the footage, you might see moments where things don't go perfectly. Maybe the robot drops apart. And yes, let's be clear, these machines, like their human counterparts, will make mistakes. Perfection isn't the goal, resilience is. Watch what happens after the error. There's no shutdown, no waiting for a human technician to intervene and reset everything. The robot recognizes the error. It understands that the dropped part signifies a deviation from its objective. It then intelligently assesses the situation, executes a recovery procedure, like locating and retrieving the dropped item, and seamlessly resumes its work without missing a beat, all without human intervention. This capacity to adapt on the fly, to learn implicitly from mistakes, even if it's just adjusting its parameters for the next attempt, and to operate independently for extended periods without needing constant oversight. This is what elevates Figure 02 beyond nearly every other humanoid robot demonstration we've witnessed to date. It's the difference between a tool that needs constant supervision and a true robotic colleague. What amplifies the shock value of all this is the sheer speed of progress. Let the timeline sink in. Just 6 months ago, demonstrations of this same robot typically involved carefully controlled environments, simplified, repetitive tasks, and often significant human guidance or setup. Now, half a year later, it's navigating the messy, unpredictable, dynamic reality of an active BMW factory floor. If this rate of improvement, this exponential curve of capability, continues, we need to drastically recalibrate our expectations. We're not discussing widespread adoption of useful humanoid robots in some fuzzy, distant future decade. This transformation feels like it's happening right now, unfolding before our eyes at an accelerated pace. Make no mistake, BMW's partnership with Figure AI isn't a flashy publicity stunt or a short-term R&D experiment. This is a strategic move by a major industrial player preparing for a fundamental shift in the nature of manufacturing. While the initial deployment involves a small number of robots, sources suggest that internal roadmaps and planning documents outline ambitions for integrating hundreds of Figure robots across various BMW factories within the next 2 years. That's not a trial, that's scaling. And automotive manufacturing is just the proving ground, the first beachhead. Once these humanoid systems demonstrate their value, reliability, and cost-effectiveness in the demanding environment of car production, expect a rapid domino effect. The potential applications are vast. Logistics and warehousing. Imagine robots navigating vast fulfillment centers, picking and packing orders, loading and unloading trucks, operating 24/7 with tireless efficiency. Construction. Picture humanoids performing strenuous or dangerous tasks on construction sites, lifting heavy materials, working at heights, operating in hazardous conditions, potentially around the clock. Disaster relief. Deploying robots into zones unsafe for humans, searching collapsed buildings, handling hazardous materials, providing logistical support in emergency situations. Healthcare. Assisting nurses and doctors with physically demanding tasks like patient lifting and transport, delivering supplies, potentially even performing routine monitoring or assistance in elder care facilities. Retail. Stocking shelves, managing inventory, potentially even assisting customers in certain capacities. And eventually, even the home, handling household chores, providing assistance for the elderly or those with mobility issues, becoming integrated into our daily lives in ways we're only beginning to imagine. The business implications are stark and undeniable. These robots don't adhere to traditional labor constraints. They can operate 24 hours a day, 7 days a week, without needing breaks, vacations, or sleep. They don't experience fatigue, which can lead to errors or accidents in human workers performing repetitive tasks. They can be reprogrammed and redeployed to different tasks or locations relatively quickly as production needs shift, offering unprecedented flexibility. And crucially, based on projected costs for acquisition, operation, and maintenance, analysts predict they will rapidly become more economical than human labor for a wide range of repetitive, physically demanding, or potentially hazardous jobs. Now, it's vital to address the elephant in the room: job displacement. This isn't necessarily about replacing every human worker overnight. The narrative, at least initially, focuses on augmentation. The idea is to enhance human teams by introducing tireless, precise robotic teammates capable of shouldering the dull, dirty, and dangerous tasks, the monotonous assembly line work, the heavy lifting, the operations in unpleasant or unsafe environments. This, in theory, frees up human workers to focus on more complex, creative, problem-solving, and supervisory roles, tasks that still require human ingenuity, adaptability, and interpersonal skills. However, the long-term societal and economic adjustments required by this shift will be profound and require careful consideration and planning. What truly seems to differentiate Figure AI in this increasingly crowded humanoid robotics space is their almost obsessive focus on practical utility. While others were chasing those viral moments, the backflips, the dancing figure was quietly grinding away on the unglamorous, yet absolutely critical, problems that gatekeep robots from real-world effectiveness. Think about the mundane challenges. How does a robot reliably open different types of doors? Push, pull, knob, lever, sliding. How does it navigate smoothly around an unexpected obstacle, like a dropped box or a person suddenly stepping into its path? Crucially, how does it recognize when it's truly stuck, when a task is beyond its current capabilities, and effectively ask for help from a human colleague? These seemingly simple challenges are monstrously complex from an engineering perspective, and solving them is the key that unlocks robots from the lab and allows them to function meaningfully in our workplaces. The AI architecture powering this capability is equally impressive and represents a convergence of cutting-edge techniques. Figure's neural networks are trained using a revolutionary hybrid approach. It leverages the power of simulation, where the robot can practice tasks millions of times in a virtual environment, learning the basics far faster and cheaper than possible in the real world. But crucially, This is combined with real-world data and reinforcement learning. A skill initially learned in simulation can then be rapidly refined and adapted through just a few physical attempts in the real environment. The robot learns from its real-world successes and failures, constantly updating its internal models. This hybrid methodology means the robots aren't just programmed. They are continuously learning and getting smarter, more capable, and more adaptable at an unprecedented rate. Underpinning this learning process is a sophisticated system architecture. A multimodal perception system. This isn't just about cameras. It fuses data from vision, potentially auditory sensors listening for cues or commands, and tactile sensors, the feeling in its hands, into a single, unified understanding of its environment. It's like how humans combine sight, sound, and touch to navigate and interact with the world. A hierarchical control architecture. This allows the robot to operate on multiple levels simultaneously. High-level planning determines the overall goal, e.g., install this component, while low-level control handles the instantaneous, reflex-like adjustments needed for smooth movement, grip control, and balance. Much like our own brains manage complex actions without conscious thought for every muscle movement. A continuous learning framework. This ensures that every task performed, every mistake made, every successful interaction contributes to the robot's ongoing improvement. It's designed to get better over time, naturally, through experience. Looking ahead, the next milestones for Figure AI and the field seem clear. We'll likely see efforts focused on achieving longer operational periods between any necessary human interventions, pushing towards true lights-out operation for certain tasks. The complexity of tasks will increase, moving from single-step actions to more complex, multi-step assembly processes or sequences requiring tool changes and coordination. And eventually, the goal is true collaboration, not just between humans and robots, but between multiple robots working together cooperatively on a single task or assembly line, coordinating their actions seamlessly. The version of Figure 02 we're seeing deployed at BMW today is undeniably impressive, but the Figure team themselves emphasize that this is merely the baseline. The truly significant leaps in capability, intelligence, and versatility are reportedly still on the horizon. The impact on the industry is already palpable. Industry analysts are scrambling to revise their predictions. Forecasts that suggested meaningful, large-scale factory deployment of humanoid robots was still 5, 7, or even 10 years away are suddenly looking deeply conservative. Figure's progress indicates this revolution is likely to happen much, much faster. Early adopters like BMW are positioning themselves strategically, hoping to gain a significant competitive advantage in efficiency, quality, and flexibility. You can bet that other major manufacturers across various sectors are now watching very closely, likely accelerating their own robotics R&D and partnership explorations. The fear of missing out FOMO in the corporate world is a powerful motivator. And the implications, as we touched upon, extend far beyond the factory floor. As these humanoid robots prove their mettle in demanding industrial settings, the core technologies, the AI, the sensors, the actuators, the control systems, will inevitably mature, become more robust, and decrease in cost. This will pave the way for their migration into countless other sectors. Construction sites, performing repetitive tasks like bricklaying or drywall installation, or hazardous ones like demolition or welding in confined spaces. Disaster zones, acting as first responders in environments too dangerous for humans, searching for survivors, clearing debris, delivering aid. Healthcare facilities, providing round-the-clock assistance with patient mobility, monitoring vital signs, sterilizing rooms, managing inventory, reducing the physical strain on human caregivers. retail and logistics, handling shelf stocking, order fulfillment, warehouse management, potentially even personalized shopping assistance. Agriculture, assisting with planting, harvesting, and monitoring crops, tasks often facing labor shortages. And ultimately, our homes, assisting the elderly with daily living, performing household chores, providing companionship or security, transforming domestic life. For anyone who remained skeptical, who dismissed humanoid robots as niche novelties, expensive toys confined to research labs, or just elaborate publicity stunts, this BMW deployment serves as a powerful, undeniable wake-up call. The future isn't some abstract concept slowly approaching over the horizon. In a very real sense, it's already punched in, clocked on, and is working diligently on the factory floor, right beside its human colleagues. The pivotal question is no longer if these humanoid robots will transform industries, but how quickly that transformation will sweep across the global economy. And one thing seems absolutely certain: Figure AI, through its relentless focus on practical application and real-world deployment, has dramatically raised the bar for what's possible in robotics right now. Their approach validates the idea that focusing on solving tangible, real-world utility problems ultimately trumps flashy, but less functional, demonstrations every single time. As more companies inevitably recognize this strategic advantage, we are likely poised on the brink of an acceleration in adoption and capability development that will make even today's impressive achievements look quaint in retrospect. The age of the practical, working humanoid robot hasn't just dawned. It appears to be arriving with the speed and force of a bullet train. What we're witnessing isn't merely incremental technological progress. It's the nascent stage of a fundamental restructuring of how work gets done, how value is created, and potentially, how we live our daily lives across entire industries and societies. So as we stand here, watching these machines take their first significant steps into our world, it's both exhilarating and, let's be honest, a little unnerving. The lesson here, perhaps, isn't just about the incredible power of AI and robotics. It's a deeper lesson about the relentless pace of change and the importance of adaptability. Figure AI succeeded by focusing laser-like on solving real problems, not chasing superficial hype. For us, as individuals and as a society, the takeaway might be similar. Focus on developing skills that are uniquely human: creativity, critical thinking, emotional intelligence, complex problem-solving, and be prepared to learn and adapt throughout our lives. Resisting change is futile. Understanding it and finding our place within the new landscape is key. This technology offers immense potential for progress, for freeing humanity from drudgery and danger, but realizing that potential responsibly requires thoughtful discussion, ethical consideration, and proactive planning. What do you think? Is this Figure 02 deployment the genuine breakthrough moment we've been anticipating for decades? Or do you still see significant hurdles, perhaps ethical, economic, or technical, that need to be overcome before widespread adoption? What excites you most about this technology? And what concerns you the most? If you could assign a humanoid robot one task in your own life or workplace, what would it be? Drop your thoughts, your hopes, and your fears in the comments below. The conversation about how we navigate this new era, how we integrate these powerful technologies into our world thoughtfully and equitably, is just as crucial as the technology itself. Don't forget to hit that subscribe button and turn on notifications, because the revolution in AI and robotics is happening now, and you won't want to miss the next shocking revelation or groundbreaking development. We'll be here covering every step of the way. Until next time.